Self-dividing numbers. A self-dividing number is a number that is divisible by every digit it contains. So for example, if we had the number 128, we have to check if 128 modulo 1 is 0, 128 modulo 2 is 0, and 128 modulo 8 is 0. And if in all these cases the result is 0, then that number is a self-dividing number. Now in this problem, they're going to give us two int variables called left and right, and we need to find all the self-dividing numbers within this range, within the range of left to right, including the numbers left and right. So for all the numbers between 1 and 22, so 1, 2, 3, 4, 5, 6, all the way up to 22, what we need to do is we need to find all the self-dividing numbers and add them to a list and return that list. So the very first thing we're going to do is obviously we need to create the list of integers that we will return. So list integer result equals new linked list. Now what I'm going to do, in a while loop, I'm going to iterate while left is less than or equal to right. And obviously by the end of the block of code that we write in this while loop, we're going to increment our left so we can investigate the next number up until we hit right, where we will also study the number for right before we exit our while loop. So I'm going to delete this left plus plus for now, and I will add it later. So now what I'm going to do is, in our while loop, for each iteration, I'm going to create an int variable called I, which is going to be equal to left. Now the idea is we're creating a variable I, which is equal to left, so the value of I is going to be the value of left, and I'm going to be modifying our value of I so we can leave left as is, and in the case where it is a self-dividing number, then we just add left to our list. But I do need to modify a number or a variable so I can actually see if it is a self-dividing number. So let's see what that looks like. So what I'm going to do now is, in another while loop, I'm going to keep iterating while I is greater than 0. And now in this while loop, I'm going to create an int variable called y, which is equal to I modulo 10. And this is where the I comes in handy. If I were to use left modulo 10 in the end of this while loop, so I can study every number in left, I would have to do something like left is equal to left divide by 10. That way, if we had a number like 128 stored in left, then after this statement, our 128 is going to be just 12, and I can no longer add that number to the list. So instead, we're going to create a temporary variable called I and y to modify our left variable, see if it is a self-dividing number through all the numbers within it, and in that case, we just add left in the end. So this will make more sense as we code. So int y is equal to I modulo 10. Now something I want to mention in the description is a self-dividing number is not allowed to contain the digit 0. That means any number that contains the number 0, instantly we have to skip it. So numbers like 10, 108, 20, 120, so on and so forth, we have to skip these numbers. So I'm going to add an if statement, and I'm going to check if y is equal to 0, then instantly break from our second while loop. So from this loop. Now a quick thing I want to mention is y equals I modulo 10. This will give us the last digit in our I variable. So 128, int y is going to be equal to 8. And then if we update our I, now what I'm going to check is if left modulo y is not equal to 0, then also we instantly break because it's not a self-dividing number, and we can just go to the next number. Finally, else if left modulo y is equal to 0 and I is less than 10, then add to our list called result.add the value of left. And in the end, we want to update our value of I. Okay, so briefly, let's say we had left is equal to 128. I is going to be equal to 128. Is 128 greater than 0? Yes, it is. So create an int variable called y, which is equal to I modulo 10, which means y is equal to 8. Is 8 equal to 0? No. Is 8 modulo, or is 128 modulo 8 not equal to 0? It is. So we also skip this. And is 128 modulo 8 equal to 0? Yes. But is I less than 10? It's not. What does I less than 10 mean? So if you notice, after this statement, we're updating our value of I. We're dividing it by 10. So 128 becomes 12. And then we repeat this while loop because y is now going to be equal to 2. That's the next digit we have to check if 128 is divisible by 2. So I is less than 10 means that we're on the last digit of our left value. So if I is less than 10, that means we saw the 8, we saw the 2, and we saw the 1. So after that while loop, we can increment our left plus plus so we can see the next number. And in the end, we need to return result. So let's submit our code and see if it works. Accept it. So that was the self-dividing number problem on LeetCode. I hope you found that video helpful, and thanks for watching.